In this video, we'll look at mutually exclusive or not, and we'll determine some probabilities. So, looking at the question, it says the 8 members of the debating club pose for a yearbook photograph. If they line up randomly, what is the probability that A, either Hania will be first in the row or Aaron will be last? So let's make a couple of quick notes here. There's 8 people. And we want to think about what it would look like for Hania to be first. She would be here, and there would be 7 other spots. 1, 2, 3, 4, 5, 6, 7. That would be Hania first. And what would it look like for Aaron to be last? That would be these 7 spots here. 1, 2, 3, 4, 5, 6, 7, and Aaron would be last. And then there's this idea of Hannah is first and Aaron's last, with 6 spots in the middle. That's going to help us in a sec. 1, 2, 3, 4, 5, 6. Why? Because we want to calculate, the question asked, the probability that either Hania will be first or Aaron will be last. So the probability of Hania first, or, I'm going to underline it so I don't forget, or Aaron last. Well, that's just the probability that Hania is first, plus the probability that Aaron is last. So we just add those probabilities together. What's the probability is Hania is first? What's the probability is Aaron last? But they can both happen at the same time, which means we're going to count Hania first and Aaron last with this one, and we're going to count this situation also when we look at Aaron last. Like, this case includes the overlap of when they both happen. So does this case. In other words, we count the HA case twice. We count the Hannah's first and Aaron last twice. So we have to subtract off one of those times. We take off the probability that Hania is first and Aaron last. Okay, now we've set it up. Now we can start to solve. What's the probability of Hania being first? Well, if we fix her in the first spot, then we have 1, 2, 3, 4, 5, 6, 7, 7 factorial people to arrange. Out of a total 8 factorial ways, if Hania wasn't first, there'd be 8 factorial ways, or 8p8 ways to arrange the people, because order matters. What's the probability Aaron's last? Very similar. We fix Aaron in the last spot, then we have 7 factorial ways to arrange everybody. Out of, if we hadn't fixed Aaron there, there'd be 8 factorial ways to arrange everybody. So that's the probability of Hania being first, and that's the probability of Aaron last, but we've counted the case twice where Hania's first and Aaron last. We counted that in this first one, and we counted it in the second one, so we have to subtract the situation of Hania is first and Aaron is last. Well, the probability of that happen would be, that can happen 6 factorial ways out of a total of 8 factorial ways. That could have happened. Just the general way to organize everyone, no restrictions, is 8 factorial. The number of ways that they can be Hania first and Aaron last, there are 6 factorial possibilities. So when we go to put that all together, we'll get 7 factorial. You can do it in your head if you've learned what 7 factorial is, you just memorize it. Just by doing it so much, it's 5,040 over 4,040. Let's check it just to be sure. What's 8 factorial? Yeah, 40,320 plus another 7 factorial, which is 5,040 over 8 factorial minus, and again 6 factorial, you might have it in your head. You can use a calculator if you need it. Oh, if you need it. 720 again over 40,320. So when you're adding and subtracting fractions, you just add and subtract the numerators, leave the denominator alone. You can watch a video on that. What's 5,040 plus 5,040 minus 720, and you get 9,360. So probability can be left as a fraction, but then I'd have to reduce So I'm going to convert it to a decimal instead. I don't have to reduce. And I get approximately 0.232. Now you can leave it as a decimal or write it as a percent. The probability is 23.2%. That is, there's a 23.2% chance that Hania will be first, or, which means and or, Aaron will be last. Question B is a bit trickier. It says, what's the probability Hania will be first and Aaron will not be last? So what's the probability of Hania first and Aaron not last? Well, that's just equal to the probability that Hania is first. So far, pretty straightforward. I want the probability of Hania first, but then I'm going to take away the probability of Hania first and Aaron last. And so this is probably the tricky part of the question, is just figuring this part out. I'm going to take all the cases where Hania's first, here she is being first, and then I'm going to subtract away this case where Hania's first and Aaron's last. Because if I subtract away all these cases, Hania's here, Aaron's here, if I take away all these cases from this, what I have left over will be all the cases where Hania's first, but Aaron's not last, because I'm going to take away the cases where Aaron's last. So how many ways are there where Hania can be first? Well, we already figured that out. It's just 7 factorial over 8 factorial. Take away the probability of Hania's here first and Aaron's last. How many ways can that happen? Well, there are 6 factorial over 8 factorial ways. We knew that from the last question. So if we take this away, we'll be subtracting out all the cases where Aaron's last. And now it's easy to figure out. We already know what these fractions are from the last question. It's just 5,040 over 40,320 minus, what's 6 factorial? 720 over 40,320. Again, you're subtracting fractions. Just want to do the number on the top minus the other number on the top. Leave the denominator alone. You can watch a video on this if you need to work with fractions a little more carefully. Otherwise, we've got our fraction. Let's convert it to a decimal by dividing. And we get approximately 0.107. Therefore, the probability in this situation is approximately 10.7%. So this was a couple of different word problems in the same situation, thinking about mutual exclusivity or not, and determining the probability.